Hi and welcome back. In the previous video in this Linux OS development series, we covered creating a custom memory allocator. In this video, we're going to modify our shell program to execute external executable programs and pass arguments to them. So let's get started. First, we're going to need to add a couple new syscalls. So let's start by opening up our syscall, sys.c. Well, first let's go to the website that has the list of syscalls. Now, I need to add a close method first because I never added the close file descriptor. But the main one I'm going to focus on here is stat. So it takes in a file name and then a stat buff struct. We can look at the man page here, and these are the includes we need, and I'm just going to copy that and put it into our header file. Go to our header file, I'll paste this in here at the top, and I'll make this extern sysstat. So this will tell us the status of a file name that we pass in. Stats about the file. And I'm going to add a sysclose as well. And that takes a unsigned long file descriptor. So that's the file descriptor that we want to close after we open it. So take those over and put them in the sys.c. And these are going to be just as easy as the other syscalls to implement. We just return the underscore syscall and pass in these arguments, sysstat, give it our path name and our stat buff. And same for sysclose. And the file descriptor. And then zeros for everything else. I have to do that up here as well. Zeros for all the other arguments. Okay, so let's go back up to terminal. Now let's build this and install it. So we'll cd into the mylib folder, make sudo make install. So now we have those new functions in our library. And now before we can actually pass arguments into other programs, we need to modify this crt.s. Right now we're just calling main, but actually we can Google this libc crt0.0, and the Wikipedia has a good implementation for it. What I'm going to do is just copy and paste that because that's for Linux x86-64. So I'll just take all this here. We can just put it straight in our crt0.s file. And you can see it's got up here, it's setting up all the variables that are needed to pass into main, and then calls main, then sets up the variables to pass to exit and calls exit. So we're going to have to actually implement that underscore exit as well. We can put that down in maybe sys.c, or probably util.c would be better. And this implementation is very simple. Just underscore exit into the code, and we can return underscore syscall sysexit, pass in the code, and let's actually look at the page for it. So if we find exit, it should be down here. There it is, number 60. All it takes in is error code. So that's the error code that a program would normally return from their int main. So when the exits, we just want to call sysexit. Alright, now that we have that, we can actually build this, and let's go into the init program, and actually we can just use GCC to build this. We use the -c to compile it, and the output file is going to be our old CRT0_s.o. So there you go. That's all that we really needed to do. So now whenever we execute, oh, what do we have? Unreferenced exit. What did I miss? That's in CRT0.s in function start. So let's go back to mylib. Oh, we gotta remake mylib and make install. Now we can go back to init, make, and there we go, no errors, and make install. So now whenever we execute a program, it's actually going to pass the arguments that we give to it. So now, next I want to take our Lash program and convert these commands. I'm going to make it a big else if block for now. So that if we don't actually type one of these specific commands, then we're going to fall into our section that's going to actually look up the command to see if it exists on the hard drive. So we'll say an else block, else if sysstat. Actually, let's just make it a regular else. And we got to set up our stat buff. Let's see, struct stat, is that what it was? Mylib stat. Yeah, struct stat staff buff. So I'm just going to copy that. Bring it down to here. Just paste it and take off that pointer reference. So now I'm going to call if sysstat pass in the path name, which will be the command that we typed, and the address of our stat buff. If that equals 0, then that means that the file actually exists. So it is a file on the file system. It might or might not be executable, but for now we're just going to find if it exists and try to execute it. Won't get too fancy yet. So now I'm going to go up above the process command function. I'm going to create a new function that returns a char pointer command to args. So whatever command you type in, I want to convert that to an arguments list. So let's go ahead and pass in the command. And this is going to be a super simple implementation. Obviously it should have a lot of extra error checking and all that in a real world scenario, but for now I'm just going to do a really simple parsing of this command string into a command and arguments list. So I'm going to get the length of the command for each value in it. I'm going to calculate the number of spaces. So if that specific index is a space, I'm going to say change it to a 0. So that'll be a null terminator. Number spaces plus plus. Actually, arg is not the right word. I should use command. Alright, so this is going to be our char pointer argv. So that is going to be equal to, and what I'm going to do is allocate the size of char pointer times the number of spaces plus 1. Alright, so now that we have that, we're going to get our current item is currently the null terminator. And actually the very first one we're going to have as the command, because that's the way that commands passed in are treated. in C. Alright, so now we're going to for into each of these, actually for through the len. Let's see, if command I is the null terminator, then we know we've hit a new command. So argv plus plus current item is going to be equal to the command plus the index plus 1, because we want to skip past that 0 terminator. Let's see. So now argv plus plus cur item equals 0. So we want to set the very last item to a null terminator right at the start. And we can return the argv. Now we're gonna, since we malloc that, we're gonna have to free it eventually too. So now we can take this function, we can remove a lot of this extra stuff up here, replace it with this argv equals command to args and passed in the command. We're going to have to refactor this code a little bit here. Let's see. So actually argv0 would be the command, and then argv1 is going to be that first argument for this function. argv1. We can leave cmd as is because it's null terminated right now. This 2, let's see. We can take out this extra parsing. We don't need that anymore. Let's just take a look at, so this is the second argument. We can just say that val equals argv2 and take out all that junk. That should be it for that. And then fetch, we can just use argv1. Alright, there we go. So now let's see. Actually, I'm going to move this up into a variable. We'll call it bool exists equals sysstat equals 0. And we want to look up the to see if the command exists in the bin directory as well. So let's see, the bin exists. Actually, I think what we need to do is just create another function. So we'll create a function that will look for the full name that the user typed, or that the command exists in the bin directory. So I'm going to create a char sz, well, we'll just call it char full path. For now, let's just use 64, I guess. Alright, so if we're going to call the function find command, we'll pass in the full path. Actually, first we're going to stir copy the command that the user typed. That's the first argument. So we're going to find out if that command, if the first argument of the command exists. Let's create this function. We'll just make it return a bool. Our full path. So the first thing we're going to do is check the sysstat for just the file name as the user typed it. So you copy this up here. Alright, so sysstat, pass in that full path and our stat buff. So if that equals 0, then we know that the command as the user typed it exists. So they could have typed the full command /bin/program, So otherwise, what we're going to use is the sprintf, and we're just going to append bin onto that. So we'll just use full path there, append bin, and we'll do the same thing here. So if now a full path with that bin on it, and we'll return false if that doesn't return true. So now we can replace this here. We still need the stir copy. Alright, so if find command, let's see, so what we're going to want to do here is call fork. So if the command does exist, we're going to call sysfork. If you remember from one of our previous examples, this returns you the process ID, and if it's 0, then you're in that new process. So now we can invoke the command that we want to in this new forked process. So char envp, which we don't care about the environments yet. Now we're going to call sysexecve, pass in our full path, and then the arguments argv. So this is just going to be basically that argv that we processed up here, because if you remember, it takes in the first command as a part of it anyway, and pass in envp. Alright, so now if we create new programs, we should be able to execute them. Oh yeah, at the bottom here I want to free that that memory that I allocated for the argv. Okay, so now let's go up and just create an actual new program. We're going to call this print args. So this is just going to print the arguments that we pass to it. We're going to copy the make file from lash and just change the name up here to print args. Let's see if all the rest of this, yeah, we'll put it in bin. Everything else looks good. So let's just create a new C file, and this is going to be the super simple C file. So first we want to include mylib. What else do we need to include? Printf as well. So now we're just going to do a simple main. So it's going to have the arg count, argv. We're not going to worry about environment p. So now we're just going to call printf. We're going to say print args, and then we'll print the number of arguments. So argc. So now we're going to loop from I equals 1 to I is less than argc. We don't want to print out arg0 because that's just the command name. So this is going to print the commands that are passed to the command. So we'll put a tab. We'll say, so argument number equals, and then a string. So we'll say I and argv I. And let's see, we'll return 0 at the end. So super simple program. Now let's go into our part 7, ls, go into source, clear. Alright, now we need to go into our print args folder. We'll call make, and make install. There we go. So that's copied to bin. So now if we go back to lash, build that, and make install, and now we should be just about ready. Actually, before we start testing this, let me go back to lash here. So we're going to call execve find command. So inside find command, I'm going to actually create another variable. So instead of full path, I'm going to call it, let's say, bin path 64. So what I'm going to first do is sprintf bin path, the full path, stir copy into full path that bin path, because this sprintf function that I copied from elsewhere doesn't really work that great, so it's kind of like a bug fix for it. So now we sudo make install that. And actually before we reboot, there's one more thing I gotta fix. Let's see, down here, envp, this should be char pointer or to an array. Yeah, otherwise it's gonna crash when you try to call it. So let's go back and actually I'm gonna add a check here to see if you type just a blank string, because otherwise it's gonna try to. And also I want to take this string here so that when you do type and enter, it's actually going to print the prompt again for you. So let's go back into Lash, make, sudo make install. Now we're ready to reboot. So now if we boot it up, go to MyOS, Linux kernel starting up, initializing MyOS, and now we type enter, we can see we got the prompt still. Type ASDF, it just ignores it. And now if I print args, we'll say ABC 1, 2, 3, 4, 5. Now you can see it actually executed our program. So there's our output. Print args7, the very first argument's ABC, then 1, 2, 3, 4, and 5. Okay, so there you have it. We can create a new executable program and invoke them by passing in arguments from our simple shell. Now that we have this ability, in our next video I want to start going over how to change the video mode and resolution of the screen. I hope you enjoyed this video and learned something. If so, please like, comment, subscribe, all that, and please let me know any specific topics that you'd be interested in me covering. And thanks for watching.